Now we can see the low power can be reduced in the architecture level and the system level. So what is the effect of glitch reduction in the architectural system? How it can be eliminated? So glitches are unwanted switching activities that occur before a signal settles to its intended value. They are caused by transition at multiple inputs of a gate within a clock cycle. Glitches are undefined and unpredictable behavior of a circuit that cannot be analyzed deterministically. Glitches of a signal node are dependent on the logic depth of the node. A logically deep node is typically affected by more primary input switching and therefore more susceptible to glitches. One way to reduce glitches is to shorten the depth of combinational logic by adding pipeline through registers. Parallel architecture with the voltage reduction. Parallelism has been traditionally used to improve the computational throughput of high-performance digital systems. Parallelism essentially trades off area for a lower operating frequency or higher throughput. The same trade-off idea can also be applied to achieve power reduction. In a uniprocessing system, the power dissipation, this is the formula. It has single processor, it has a capacitance supply and the frequency. So this is the power and relationship. Okay, dynamic power relationship. C is the average capacitance which reads the operating voltage for the uniprocessing system. The power of parallel system is given by, you assume the capacitance is 2.2, okay, then the voltage is reduced this much, totally the 40% reduction, okay. This is exactly parallelism means the frequency is half. So compared to uniprocessing system, if you apply the parallel technique, that is the power is saved this much percentage. 60% of power is reduced by parallelism technique. So how this can be achieved? This is uniprocessing system. This is uniprocessing system. The same can be given in the parallel mode. The same thing is given parallel mode. The frequency is exactly half, this one and this one. Okay. So what will happen? This capacitance and this capacitance, if you connected a series, it comes under series. So you will get the total capacitance is this much. It's reduced. Similarly, the voltage is reduced 40%. The frequency exactly 50%. So the total power is the total power as P is reduced by 60%. Power efficiency by pipelining. The above parallel technique increases the chip area by at least twice. Okay, but the pipelining is offer similar trade-off results with less area overhead but more complexity in control design. So this is nothing but, if you including the register between the architecture is nothing but a pipelining. Okay, this is single architecture. The power is equal to CV squared. Power is equal to CV squared F. Okay, this is simple. Now you take a pipelining structure. You have a register, this half register. So the processor are divided, in between this the registers are included. So what will happen? The capacitance is in a parallel, so it is reduced by this much percentage. This is voltage, no change in the frequency. So here 64%, that is 54% of the power is reduced by using the pipelining technique. So the glitches are occurred in the architecture level because the many signals is given to the processors and the logics present in the architecture. So the many signals and clocks are introduced between glitches input and output. The glitches can be avoided by the use of parallel and the pipelining process. If it is a parallel process, the 60% of the power is reduced. Similarly, if you take a pipeline, the circuit is complexity because there is a control, but the power is 54% is reduced.